In this video, I'm going to teach how to find the second derivative of a function fx. The process is very simple. We do the first derivative of the function given fx. So from fx we get f dash x, which is the first derivative, and if we do the derivative of the given derivative, we get the second derivative. Second derivatives are extremely important topic for the practice test, as well as it comes in a lot of exams in school where we are supposed to find minima and maxima. To help to solve those equations and those problem solving questions, we use second derivative in a lot of instances. In some books, the first derivative is given as dy by dx, so the function given is y. If I do the first derivative, it is dy by dx, and if I continue finding the derivative of the first derivative, we get d2y by dx square. Let us take an example and try to see how to find the second derivative of a function and then how to solve the equation. So in this equation, the function is given as x cube minus 2x square plus 5x minus 1. So let us take the first derivative. So f dash x will be 3x square minus 4x plus 5. And we know the derivative of a constant is 0. So derivative of minus 1 becomes 0. So now if I still continue doing the derivative of the first derivative, which we got already, let's say it is given by f double dash x, 3 to the 6x minus 4. The same rule, the derivative of a constant becomes 0, so derivative of 5 is 0. Now we have done the first part, which was that how to find the second derivative of the function given fx. Now let us go to the second part, which says that we have to solve the equation when f double dash x is 0. So let us solve it. So it means f double dash x is given equal to 0. And what is f double dash x? Let us put the number here. So we get 6x minus 4 equal to 0. Let us rearrange 6x equal to 4. And if I want the value of x, it is 4 on 6. If I further simplify, it is 2 by 3. So the answer is x equal to 2 by 3. Now, second derivative can be used in various applications in maths as well as in physics. The most common applications of second derivative is to find the local minima, local maxima of some graphs of some functions. A lot of time you want to know whether graph is up or down. We call them concave up, concave down. In physics, if I do double derivative, it gives us the value of acceleration, and it is very useful process to find acceleration from displacement to velocity, from velocity to acceleration. Similarly, we can find the points of inflection in mathematics, and when we go to advanced maths, double derivatives helps us to solve differential equations. If you want to know more about this, please contact Newton Classes Australia, and please definitely subscribe our channel. Thank you.